I study collective behavior in a bunch of different areas. So normally I'd be getting up here to tell you about robots, or about social insects, or designing molecules. But this is the thing I think is really important to talk to you about. 10 years ago, my sister decided she wasn't sure anymore that she still wanted to have kids, because she'd become worried that the world they'd grow up in was going to be a post-apocalyptic disaster movie. And that's my fault. I'd been doing some research in evolutionary theory, which sounds like a very academic topic, right? And very much focused on the past, really not relevant to our actual lives today. But some of the implications of what I was studying, together with things going on in the world, got me really worried about conclusions that I couldn't avoid drawing. It started with looking at the evolution of cooperation, which is kind of a surprising thing if you think about it. If evolution is driven by competition, right, and an organism's main competitors are others of its own species, then why should cooperation be as successful as it apparently is? The accepted explanation is about shared genes. So I may do something that looks like I'm being helpful, but actually I'm helping you only because, and only as much as, we have genes in common. So I'm actually acting in my own self-interest, even if it doesn't look like it, because I'm acting in my gene's interest. And the standard theory says that organisms doing things not in their own interest is impossible. If you've got two versions of an organism, one that's self-sacrificing and one that's selfish, the standard theory says the selfish kind should win, right? It should out-evolve the other, and it should survive while the self-sacrificing type dies out. The thing is, that established theory is based on a hidden assumption, which is that everything is mixed together. Essentially, everything is happening in the same place. Anything that happens anywhere affects everyone equally. But if instead things are spread out in space, so we call that a spatial system, so that things can be different in different locations, then everything changes. So let's look at a very simple model. Suppose you've got some organism of interest, and it consumes some resource. And this is a general model. It's very abstract. This could apply to predators and prey, could describe herbivores and plants, could be bacteria. The only important thing here is that you've got these two interacting types, one of which lives at the expense of the other. So both these organisms and these resources can reproduce themselves, and the organisms consume the resources. And the evolution comes into this model by letting the organisms change how fast they're reproducing. So any particular organism has a fixed reproduction rate, so that's set by its genes. But when it reproduces, there can be some mutation, and the offspring can have a value that's a little bit higher or a little bit lower than the parent. And then you can ask, how does this reproduction rate evolve in the population over time? Well, if everything is mixed together, if all of the resources are in one pooled supply and everyone has access to it, then what you see is this rate increases over time. It just keeps on increasing, which makes sense. If you're reproducing faster, you'll tend to have more offspring. They will tend to inherit your higher reproduction rate. And so there's always this advantage to reproducing more and using more resources. But if instead things are spatial, if reproduction and consumption are happening only locally, and what happens in one place affects only the nearby area at first, it doesn't immediately affect everyone everywhere, then what you see is very different. The reproduction rate increases at first, but then it stops. It reaches an equilibrium, and it doesn't keep going higher. And in fact, if you start off the population reproducing faster, it'll actually evolve to fall to that equilibrium level. So this is a completely different result. In the mixed case, more consumption always wins. In the spatial case, restraint always wins. Okay, so what's going on here? Why is there this difference? So if you look at the spatial model running in a simulation, you can see that the population organizes itself to have this sort of patchy structure. And in particular, there's a limit to how far and how fast the organisms can spread before they run out of resources. So suppose you've got two types of these organisms, one that's reproducing fast and one that's reproducing slow. Well, in a head-to-head competition for a single patch of resources, the fast type is going to have an advantage, right? It's going to be able to grab more of those resources for itself. But if more resources aren't becoming available as fast as they're getting used up, then at some point, that fast type is going to run out of resources, and it's going to die out. And then surviving slower ones from somewhere else can come in and repopulate that area. And you can see that happening in this graph over time. If you look not just at the average reproduction in the population, but if you look at the maximum, you can see places where a faster reproducing type shows up. And it does well for a while. This fastest rate in the population keeps increasing, and it keeps increasing, and then it suddenly falls. And that's where that type ran out of resources and died out. And that happens over and over again. And it's those local, separated extinctions that make it possible for the population overall to have this limitation, this equilibrium. Now, if you go back to the mixed case, you can't have a local extinction here. There's no such thing as local. And if you watch what happens as this runs for longer, what you see actually at some point is global extinction. Everyone dies everywhere. It's the same thing that was happening to little subpopulations in the spatial case, but here it has to happen to the whole population. If everybody's eating out of the same pot, everyone has to pay the penalty of using too much. So, what this model is telling us then is why is there cooperation and restraint in nature? Because nature is spatial. Things are spread out. And there is always an advantage in the short term to consuming more, and you keep getting types showing up that do consume more, and then they push things too far, and they kill themselves off. Now, it turns out that that's true also of human beings. Repeatedly throughout human history, local societies have arisen and then vanished, where a major contributing factor has been overexploiting their resources. It's happened multiple times in Polynesia. It happened to the Maya in Central America, to the Norse in Greenland, to the ancestral Puebloans in the southwestern US. The list goes on. And there are a number of recurring elements in what happened in each of these historical examples. Wide-scale deforestation, soil erosion, extinctions of species. This list goes on too. And of course, these are all things that are happening right now in a major way, along with plenty of other examples of resources that were in the process of depleting. And the timescale on depleting them is not centuries, it's not millennia, it's decades. And the difference now is, all of these are global resource issues. We're now operating at the scale of the entire world. And the world is now connected. Things that happen in one place do affect people everywhere. For the first time in history, we've essentially made our world a mixed system. And again, the thing you can expect to happen in a mixed system is for consumption to keep on increasing, to keep using up more and more resources, until eventually there's resource exhaustion and death everywhere. You remember that post-apocalyptic disaster movie I promised you? Okay, but wait, hang on. Because, look, wait, this doesn't apply to us, right? I mean, the creatures in this model are mindless automata. They're just blindly doing whatever it is that they're programmed to do. But we're more capable than that, right? I mean, we have brains. We can see trouble coming and take steps to avoid it. But that's true only if we use that ability. Because another thing that people are really good at is doing things backwards. First, deciding on something we want to do, and then finding ways to justify it. Only paying attention to evidence that supports the thing we want, and ignoring or denying facts we don't like. That's a very human thing to do. It's very easy. But it's dangerous. If we act like the mindless automata, if we keep doing the thing that seems like a good idea in the short term and ignore what we can anticipate are the long-term consequences, we know where that ends up. So, how do we avoid the extinction that we see in the model? Is the answer to disconnect the world, to split everything back up into its own little enclaves? No. No, that just makes it a local problem. Each separate area still has to deal with the same basic issue. Remember, even in the spatial system, there's still local catastrophes. If your little region gives into the short-term incentives for overexploiting, it still dies. And yes, it may be some cold intellectual comfort to know that other societies survive somewhere else. But if your society dies, that's a problem for you. So, so maybe the answer then is technology, right? This is something you sometimes hear people say in this context. It's okay, technology will save us. There's always going to be some new advance so that as we run out of one resource, another one will become available. And there has been some truth to that in our current society and its recent history. But there are a few things we're thinking about there. First, that has sometimes been true. It hasn't always been true. There are plenty of historical examples of societies that did not find another resource, and they disappeared. Do we really want to bet everything that we're always going to find a solution just when we need it? To step off that cliff and say, oh, it's okay, we'll invent a parachute on the way down. The second point is there's a difference between more resources and unlimited resources. So let's go back to the spatial model and suppose that at some point a technological advance occurs and makes more resources available. Okay, great. Then the equilibrium level increases. But there's still an equilibrium. It's still limited. If you consume without limit, you still die. A third point is this is a long-term effect. Let's suppose that you've got a population at equilibrium. So it's consuming resources at the same rate they become available, and the population size is staying about the same. And now you add to this population one more organism that's consuming faster. So that introduced one and its offspring can have an advantage over the original kind. And that can be a very major advantage that can persist for a long time. But eventually, the consequences of its overexploitation come back to bite it, and it dies out. Meanwhile, the equilibrium type survives indefinitely. And it's not obvious to one of these organisms just looking around which of these paths it's on. At this point, right, things look like they're going great, but it's important to know whether that's the real situation or a temporary state of affairs. So, what is the solution? How can we avoid the extinction that we see in the model? Well, we are more capable than the brainless creatures in the model. We can anticipate the future, and we can choose to change it. Science is our ability to understand the world and what's going to happen in it. We have to use that ability. Paying attention to reality matters. It has to be important to us, and it has to be important to our decision makers. And sustainability matters. Sustainability is just another word for that equilibrium between the resources that are becoming available and the resources you're consuming. If you keep spending more than your income and eating into your savings, at some point you're going to be in trouble. In the same way, if you really want a society and what it's achieved to last really into the long term, then being aware of that balance is important. And it's important to make it a priority to maintain it. I mentioned that 10 years ago, my sister decided she wasn't sure anymore if she still wanted to have kids. Well, people do things that are important to them. 7 months ago, she welcomed Micah. People do care about the future. What we've achieved is important to us. We want this world to last through our lives and to the next generation and beyond. And so that balance between resources and consumption is critical. And we have to be aware of that balance. And it has to be important to us to be aware. When something is important enough to enough people, we find ways of making it happen. We have to choose to be the capable planners instead of the mindless automata. Because if we don't mindfully maintain that equilibrium, the world is not going to maintain it for us. The incentives favor short-term over long-term, and the theory and the history both tell us if we let things take their course, we can absolutely expect overconsumption and collapse to be the end of the story. And one way or the other, we're going to make a choice.